Today's lesson is 12.5, Volume of Pyramids and Cones. The learning objective is, I can find the volume of pyramids and cones. So before we begin, let's take a minute to think about what did you learn from the 12.4 Big Ideas practice. You should have learned about volume of prisms and cylinders. The formula is V equals big B times H, where big B is area of the base. H is the height of the prism or the cylinder. The essential question is, how can you find the volume of a pyramid or a cone? When you find the volume of a pyramid, here's an example of a pyramid and a prism that have the same height and the same square base. When the pyramid is filled with sand and poured into the prism, it takes 3 pyramids to fill the prism. Use this information to write a formula for the volume of a pyramid. Well, if the prism is big B times H and it takes 3 pyramids to fill a prism with the same height and the same base, then the pyramid should be 1/3 of that total volume. I'm going to link a video on your Schoology too, so you can see the liquid pouring into prisms from pyramids. Over here to the right, I really liked this colorful diagram because they're showing you here how 3 pyramids that have the same base and the same height can fit together to make a cube, which in fact is a prism. The same thing is true of a cone. If a cone and a cylinder have the same height and the same circular base, then the cone, if it's filled with sand and poured into the cylinder, it takes exactly 3 cones to fill the cylinder. So if the cylinder was big BH, remember big B in this case is pi r squared because it's a circle. So a cone would be 1/3 of that. Here are your vocabulary words for this lesson. A pyramid is a solid object with a polygon as a base, and the sides are all triangles, which meet at the top at a common vertex. We also name pyramids by their bases. So if the base is a rectangle, it's called a rectangular pyramid. If the base is a triangle, then it's called a triangular pyramid. If it's a square base, then it's called a square pyramid, and so on. A cone is also a 3D solid. It also has a vertex at the top. The difference is the base is always a circle on a cone. So there would be an example of a cone. This would be a right cone. A composite solid is a 3D solid that's made of more than one solid figure. So you may have a prism with a little pyramid on top, for example. So that would be a composite solid. Here are a few examples on finding the volume of a pyramid. So number 1, we'll start with writing our formula. The base is a triangle, so we'll replace big B with the area of a triangle formula. And then the H would be the height of the pyramid. Okay, the base of the triangular base is this 6 centimeters. The height of the base is 4 centimeters. And then the height of the pyramid is 9. So that's a volume of 36 cubic centimeters. Number 2. So this base is a square. The sides are 6 inches long. So we can replace big B with side squared, and then we'll use the height of the pyramid, which is 8. So that's a total volume of 96 cubic centimeters. Always remember to put the correct units on there. Okay, volume of a cone is 1/3 big BH. Big B is a circle, so we'll replace that with pi r squared here. All right, so number 3, find the volume of the cone. So we'll substitute a 3 for the radius and a 4 for the height. That's that perpendicular height to the base. And divide all that by 3. So 12 pi would be your exact answer. And then if we rounded that, we would get approximately 37.7 cubic centimeters. Number 4, it's telling us we have a right cone with a radius of 5. Okay, so that looks like this picture here on the left where the height is perpendicular to the base, and the one on the right is oblique because the height here, you'd have to extend it outside of the cone to find the actual perpendicular height there. All right, this one has a slant height of 13 feet. So you may recognize this little right triangle right here. That is a Pythagorean triple. So if you remember 5, 12, 13 always go together. So that means the height of the cone is 12. Okay, so we'll start by writing our formula. Then we'll substitute 5 for the radius, 12 for the height. Oops, I forgot to divide that by 3. So 100 pi is your exact answer. And your estimated answer would be about 314.2 cubic feet. Take a minute to reflect on how you're feeling about finding volume of pyramids and cones so far. Here are a few more examples with no pictures. A pyramid with a square base has a volume of 128 cubic inches and a height of 6 inches. Find the side length of the square base. Okay, so let's sketch this. Each side is equal. And we don't know the measure, so we'll just call it X. The height, we'll drop that down perpendicular to the base. The height is 6 inches. So we'll start with our formula. Now this time they gave us the volume, that 128, that's going to be subbed on the left. Okay, and then we just substitute area of the square would be x times x, and then 6 is the height. Okay. 1/3 of 6 is 2. So we can rewrite it like that. Divide both sides by 2. And then we'll just take the square root. So you will have a side length of 8 inches on the square base. Okay, number 6, a pyramid with a rectangular base has a volume of 6 feet The length of the rectangular base is 3. The width is 1.5 feet. Find the height. So again, I like to start with a picture. Length of the rectangle is always the longer side. So that is 3 feet. The width will be 1.5 feet. Find the height we don't know, so we'll draw that in here and call it X. And again, they gave us volume, so we're working backwards here. So the volume is 6, so we'll sub that on the left. Area of the base would be length times width, so 3 times 1.5, and then the height we don't know. And we'll just keep simplifying. 1/3 of 4.5 is 1.5. Okay, and then we'll divide by 1.5. And you get 4. All right, so the height is 4 feet. It was X, but H for height, right? Okay, number 7, a right cone has a volume of 528 cubic meters and a diameter of 12 meters. Find the height. And there's the circular base. Radius would be 6 if the diameter is 12. It's a right cone, so we'll make that a perpendicular height. The height we don't know. That'll be our X. So again, we'll set up our formula first. Then we'll substitute. V is 528 this time. Area of the base would be pi r squared, so pi times 6 squared. The height we don't know. And we'll just start to simplify. So 6 squared is 36. 1/3 of 36 is 12. And then to get X by itself, we'll just divide both sides by 12 pi. So you should get about 14 meters. And that's the H for height. So using the same formula, just using our algebraic problem solving to work backwards to find a missing dimension. Here's an example of a composite solid. So we have 2 different cones and we will have to add them together. So the small cone plus the big cone. These are both 1/3 pi r squared times the height. So the radius of the small cone is 7. The height is that 6 value here. A third of 6 is 2, so it'd be 49 times 2, which is 98 pi. And let's leave it just like that in its exact form. We don't want to round until we get to the very end. And now we'll do the other one. So the radius is the same. The height is now 10 inches. (49 times 10 would be 490. I don't think that even divides by 3. So let's just call that 490 pi over 3 to keep it exact. Now go to the calculator and add these two together. Make sure to put 490 pi in parentheses, so it reads it as one quantity. So when you add those two together, you get approximately 821 cubic inches. I wanted to add a few extra examples from the textbook about changing dimensions. We have been over this several times with different types of solid figures. So remember, you would find the old and the new and then divide new by old, and that gives you your scale factor of change. So take a minute, read through these. If you're changing all dimensions and it's a proportional change like that, if you multiply everything by a third, k is equal to 1/3. And since there are 3 dimensions, length and a width and a height, then the shortcut would be 1/3 to the 3rd power, which would be 1/27. Now, if you only double the height, that is a non-proportional change. So you would only apply that to that one dimension. And if you're doubling, k is 2. So the shortcut would be, that it just becomes 2 times the original volume. That's because it only got applied to one dimension, the height. Again, if you don't like the shortcuts, just figure out the old volume, the new volume, and then divide new by old. Circle how you're feeling about this lesson. Can you find the volume of pyramids and cones? If you need help, please reach out. You can email me. We can schedule live chats. You can make a video request. I'm here to support you. Your practice will be due at the end of the day on Thursday. You also have an optional quizzes activity that's in the Friday Enrichment Extension folder. And if you have any questions, please let me know. Thank you for watching and listening, and I hope y'all have an easy time on this lesson.